This is part 2 of our lesson on exponential function review. So question number 2 says simplify each of the following using exponent laws. So on our yellow reference package, there is a section on our identity sheet that has all of our exponent laws on it. So there are exponent laws for multiplication. When you multiply two things with the same base, we add their exponents together. We have a rule for division. When you divide two powers that have the same base, we subtract their exponents. We have a rule for power of a power. So if I have a base with two exponents, I can multiply those exponents together. Anything to the power of 0 equals 1. A negative exponent makes a fraction. It takes our base, flips it over, and then makes the exponent positive. A rational exponent makes a root. The part on the numerator stays a regular exponent, but the part in the denominator becomes a root. And if you have a fraction to a power, that power applies to both the numerator and the denominator. So when I am doing a question and it is asking me to simplify, I try to follow order of operations. Right? So that means if I follow BEDMAS, we would start with the B, which is our brackets. So I do see that there is a large bracket here. So I'm going to start by doing whatever is inside that bracket first. Now, inside this bracket, we have division. So I'm going to start with the division because it's inside the bracket. If I divide 50a to the 9 by 10a to the 3, I would do the coefficients together just as straight division. So 50 divided by 10 is 5. But then when I go to do the exponents, I'm going to subtract those since they have the same base. So a to the 9 divided by a to the 3 is a to the 9 take away 3, which is 6. And then this is still to the power of 4. So at this point, I still have a bracket, but there isn't anything left to do inside the bracket. The bracket is really there just to show where the power is. So I would move down to the next thing in BEDMAS, which is exponents. So that would be this power of 4. So this power of 4 belongs to both the 5 and the a to the 6. So this is the same thing as 5 to the 4 times a to the 6 to the 4. 5 to the 4, you can use your calculator, you can look it up on your power sheet, is 625. And then when I have a power on a power, right, I multiply those together. So I would get a to the 6 times 4. 6 times 4 is 24. So this is going to be 625 a to the power of 24. All right, there is one more question in this section. So I have 18x to the 5 times 50x, all to the power of 3 over 2. So same thing as the last one, I would try to use order of operations to decide what order to do everything in. So up first in order of operations is brackets. I do see a large set of brackets here, and within those brackets there is some multiplication. Now these do have brackets as well, but that really is just to show multiplication. So inside the big set of brackets we have multiplication. That's what we're going to do first. So when I go to multiply these together, I'm going to do the coefficients with the coefficients as regular multiplication. So I'm going to do 18 times 50, which is 900. And then when we multiply powers, we add their exponents. So I have x to the 5 times x. That x has a secret exponent of 1. So I would do 5 plus 1, which is 6. So this is going to be x to the power of 6. And then this is all to the power of 3 over 2. I still have a bracket, but there really isn't anything left inside to do. It really is just there to separate what's inside from that outside exponent. So now I'm going to move down the list in order of operations and try exponents. That 3 over 2 belongs to both the 900 and the x to the power of 6. So this is going to become 900 to the power of 3 over 2 times x to the 6 to the power of 3 over 2. Right. We will do the number part in a second, but the variable part, when we have a power on a power, we multiply those together. When you multiply fractions, we do top times top, bottom times bottom. This 6 is secretly over 1. So I would do 6 times 3, which is 18. And then 1 times 2, which is 2. So I would get x to the power of 18 over 2, which is x to the power of 9. And then if I come back to the 900 to the power of 3 over 2, a rational exponent, so a fractional exponent, makes a root. The denominator becomes a root. The numerator just stays a regular exponent. So 900 to the power of 3 over 2 is going to become the square root. Now it's up to you whether you want to put the 2 in there or not, of 900 to the power of 3. So I'm going to use my calculator to do that. So I am doing the square root of 900. I don't need a special button for that, but if you do, it is normally the second function of your exponent button, but I'm just doing a regular square root. So I'm going to do the square root of 900 and then to the power of 3, which is 27,000. So this worked out to be 27,000 x to the power of 9. All right, that is the end of question number 2, and I will see you in the next video for question number 3.